In this video, I want to go over a few examples of how to solve for the zeros, roots, or x-intercepts of a quadratic formula, or of a quadratic equation using the quadratic formula. So we have our equation here, f of x is equal to 2x squared plus 5x plus 2. The first thing I want to do is just label my a, my b, and my c. In my generalized quadratic, it's f of x is equal to ax squared plus bx plus c. I want to just label a, b, and c so I can put them into the quadratic equation easily. Now the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you remember from previous videos, it's just a generalized completing the square. Okay, let's fill in our numbers. Negative b is negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times a times c over 2 times 2 times a. Okay, right away we can tell using the discriminant how many solutions and what type of solution they're going to be. Okay, so just think about that when we do our arithmetic here. Okay, so we have 25 minus 4 times 4 is 8. 8 times 2 is 16. Okay, so 25 minus 16, that's going to be a positive number. We're going to get two real solutions here. I don't know if they're going to be irrational or rational, but we're going to get two real solutions. No imaginary solutions here. Oops. This is 2 times 2 is 4. Okay, so now we have negative 5 plus or minus the square root. 25 minus 16 is 9. Oh, okay. Over 4. All right. So now, actually, that's very nice. This is going to give us the square root of 9 is what? It's 3 over 4. This is going to give me two rational solutions. I have negative 5 plus 3, which is negative 2 over 4. And I have, which can be reduced to negative 1/2. And I have, so x is equal to, and then I also have negative 5 minus 3, which is a negative 8 over 4, which is negative 2. Okay, that's just a quick example of how to use the quadratic formula. And this actually happened to have these rational solutions here. Let's try to get one that doesn't have rational solutions. Okay. F of x is equal to x squared plus 5x minus 1. Okay. Let's see what we got here. I'm going to plug it into my formula. X is equal to negative b, which is going to be a negative 5 again, plus or minus the square root of 5, so 25 minus 4 times a times c, all over 2 times 1. Okay, so you have negative 5 plus or minus the square root. Well, that's just 21, right? Right away, we know from our discriminant, the square root of 21, I can't do a ton with it. It's irrational, right? I'm going to have two irrational solutions here. Okay? So, there they are. Negative 5 plus the square root of 21 over 2, and negative 5 minus the square root of 21 over 2. Okay, that's as simple as this one is going to get. I hope this helps.